This video is going to demonstrate the copper lab. What you're looking at is the setup for the lab. You're going to need a glass stirring rod, a 150 milliliter beaker, a test tube rack, and a test tube holder, either a Bunsen burner with a ring stand or a hot plate with a ring stand, and another 150 milliliter beaker that's filled about halfway with distilled water. You'll need to go ahead and turn that on right away so that it's ready for reaction number 2. You're also going to need 3 chemicals, and we'll look at those, and you should observe their physical properties. The first chemical is 1 molar copper 2 nitrate. The 1 molar, or 1M, stands for the concentration. In this case, 1 mole of copper 2 nitrate was dissolved to make 1 liter of solution. For each one of these chemicals, make sure that you record at least 2 things. First, the color, and in this particular series of reactions, you're going to have a couple of blues, so be descriptive when you're writing the blue. Robin egg blue, sky blue, aqua blue, so forth. Secondly, you should record the state. If you can see through it, it means that it's liquid. If you know there's a chemical dissolved in the liquid, then it's aqueous. If you can not see through it, it means that there's a solid precipitate. And if you see bubbles, that means that there's a gas. And for a couple of these reactions, you may see more than one of those states present at one time. The next chemical is hydrochloric acid, HCl. When you're describing the color, notice that it has no color, so you will say colorless. Again, clear means that you can see through it or it's transparent. Colorless means no color. The third chemical is 1 molar sodium hydroxide, NaOH. For the first reaction, you're going to add 10 drops of copper 2 nitrate to a clean, dry test tube, and then 20 drops of sodium hydroxide, which is also aqueous, to the test tube. To mix the chemicals, you can do one of 2 things. You can use the glass stirring rod, and if you use the glass stirring rod, be careful and stir gently because the glass against the glass could cause breakage. The second way is to form a C with your thumb and index finger and then tap the test tube between your fingers. It's also an effective way to mix the chemicals. This is the equation for the chemical reaction. You're starting with copper 2 nitrate, that was the 10 drops of blue solution, plus sodium hydroxide, that was the 20 drops of the colorless solution. In this double replacement reaction, copper and sodium trade places, so the products are sodium nitrate and copper 2 hydroxide. The blue precipitate that you see in this reaction is the copper 2 hydroxide. Here's a look at the first product or set of products. You can see that the copper 2 hydroxide, the blue precipitate, is starting to settle to the bottom of the test tube, and the sodium nitrate is still dissolved in the solution, so you can't see it because it's a white solid, and when that white solid dissolves in the solution, it becomes colorless. If we take a look at the product side of the equation again, you can see we have sodium nitrate and copper 2 hydroxide, and the copper 2 hydroxide is the blue solid. The beauty of this lab is that all of the reactions occur in one test tube. So the products from this reaction will become the reactants for the next reaction. When we write the next chemical equation, however, we're only going to include the copper 2 hydroxide, and that's because the sodium nitrate is not affected by the heat in the next reaction. And chemical equations only include the chemicals or the substances that undergo chemical change. So since the sodium nitrate will not undergo a chemical reaction, we are not going to include it in the next chemical equation. So taking a look at the chemical equation for reaction number 2, you can see that we're starting with copper 2 hydroxide. You're going to heat the copper 2 hydroxide, a single reactant, and it's going to break down into copper 2 oxide and water. The copper 2 oxide will be a solid precipitate and water will be in the liquid form. This shows the copper 2 hydroxide in the hot water bath. At this point, the water should be hot, possibly starting to boil. If the water level gets low, please let me know and I will refill it with distilled water. If we use tap water in the hot water bath, it leaves a film of minerals that's hard to get out, so I prefer to use distilled water. An important step here is to make sure that all of the copper 2 hydroxide decomposes to form copper 2 oxide. The copper 2 oxide is a black solid, so you need to make sure that all of the blue solid in the test tube turns to that dark brownish black color. If it's not turning right away, you can try adding 5 to 10 more drops of the sodium hydroxide, stir it carefully, and then wait to see another minute or so whether or not it's going to turn black. If after a couple more minutes and another addition of sodium hydroxide it doesn't turn black, then you need to start over with 10 drops of the copper 2 nitrate and 20 drops of sodium hydroxide. Sometimes this reaction doesn't work. That's okay. It doesn't necessarily mean you've done anything wrong, and starting over should do the trick. If you have to start over more than once, please let me know and I will assist you. Before you start the next reaction, the copper 2 oxide needs to cool off a bit. So take your second 150 milliliter beaker, and this time you can use tap water and fill it about halfway. Put the test tube into the cool water bath and allow it to cool for about 2 minutes. If we look at equation number 2 again, we see that the copper 2 oxide solid is the black precipitate and the other product is water. So as we begin the next reaction and write the equation, we're only going to include the copper 2 oxide because water is not reactive, so it won't undergo chemical change in the next reaction. So the next chemical equation shows the copper 2 oxide, and we're going to be adding hydrochloric acid. In reaction number 3, you're adding hydrochloric acid, and you will see a dramatic color change. Make sure that all of the black color disappears, and if you had to add extra sodium hydroxide in reaction number 2, you will have to add a little bit more hydrochloric acid than the directions call for. Make sure that you stir it carefully or tap it between your fingers to mix it, and then be patient. Sometimes it takes a moment for this reaction to completely occur. This photo shows you the difference between the copper 2 chloride in the test tube and the copper 2 nitrate that you started with. Notice that the copper 2 chloride isn't just a lighter blue, but it's a slightly different type of blue, and that's an indication that the substance in the test tube is different from the substance that you started with. The next step is to test the pH of the solution. And the purpose of testing the pH is to show you that this addition of the hydrochloric acid in the previous step has made the solution acidic. Acidic solutions contain hydrogen ions, and the hydrochloric acid HCl, contains hydrogen ions. To perform the test, dip the glass stirring rod into the solution in the test tube and then take the glass stirring rod to the pH paper. Never dip the pH paper into the solution because it's saturated with a chemical indicator, and that chemical can contaminate the solution in the test tube. If we look back at the equation for reaction number 3, where you added hydrochloric acid to the copper 2 oxide, you'll see that the products are copper 2 chloride and water. So as we write the equations for reactions 4 and 5, we're only going to include the copper 2 chloride because, again, water will not undergo a chemical change. The reason we're showing 2 reactions happening simultaneously is because the copper 2 chloride is going to react with the aluminum wire in a single replacement reaction, and the excess hydrochloric acid from the previous addition of hydrochloric acid in reaction 3 is going to also react with the aluminum. In the case of the copper 2 chloride reacting with the aluminum, the single replacement reaction is going to produce aluminum chloride and copper, and then in reaction number 5, the hydrochloric acid and aluminum are going to produce aluminum chloride as well and hydrogen gas. And of course, an indication of hydrogen gas will be bubbles, and then the aluminum chloride is a white solid, and of course you can't see that because it's remaining dissolved in solution. So the aluminum chloride is aqueous. As you look at the products in the test tube, the brownish red substance is often mistaken for rust. However, rust is iron 3 oxide, and we haven't introduced iron into any of the reactions in this series of reactions. So if you take a look at the products again for the copper 2 chloride plus the aluminum, one of the products is copper. The brownish red substance is copper, and what we've done then in these 5 reactions is we've taken the copper 2 ions from the copper 2 nitrate, and the electrons that were initially lost were regained during the course of the reactions to form neutral copper metal again. A final look at that last reaction between the hydrochloric acid and the aluminum shows us that the hydrogen ions in the hydrochloric acid, or HCl, are converted into hydrogen atoms. Hydrogen ions are what cause acids to be acidic, so the fact that those ions have changed into atoms means that the solution should no longer be as acidic. Low pH numbers indicate high acidity, and then lower acidity is indicated by higher numbers. So your original pH should have been fairly low, and if you retake the pH again, because the solution is no longer as acidic, you should have a higher pH number. This concludes the tutorial for the copper lab. You may watch it again if there are parts that you are still unsure about. Make sure that you have the chemical equations written down, and as you're in lab, record your observations thoroughly so that when you take the written portion of the test, you have good notes to use. Work safely in lab, and good luck.